Hello, this is Tina, and I'm here today to help you through some very basic Excel functions that should help expedite the calculations that we've been doing over the last couple of weeks involving the normal curve. There are two functions I'd like to introduce you to today. One is norm.dist, the other is norm.inverse function, and both of these functions are available in Excel, and in a very quick series of steps you can determine what is the percentile rank of a given score, and alternatively you could determine what is the score that corresponds to a given percentile rank. So let's run through this one first. This is called norm.dist function, and this function within Excel is going to give you the percentile rank for a given score X in a normal distribution where we know the mean and the standard deviation. What's going to happen when you use this norm.dist function is that Excel will assume that higher scores are better scores. If, for example, you have golf scores or runtime scores, that is, if lower scores are better scores, you're simply going to take the answer that you get after using this function and subtract that from 100% in order to indicate the correct percentile rank. So let's solve a couple of problems like those in the homework that you will have to do for this unit. And the first question we have is, we're going to assume a normal distribution. We're going to assume a normal distribution for partial curl-up scores, and we're going to be working with females who are between the ages of 50 and 59 years. We know that the mean number of partial curl-up scores is 16, and the standard deviation is 2.5, and we're being asked to determine the percentile rank of a partial curl-up score of 11 using Excel. Now, I can look at this, and I hope you do, and you say, wow, in this case we recognize that higher scores are better. We know that the mean for women aged 50 to 59 years is 16 partial curl-ups, and the standard deviation is 2.5, so a score of 11, I hope when we do this calculation that we'll end up with something that's less than the 50th percentile. It's on the sad side of the distribution, if you will, so we can check our answer just to make sure that it makes sense once we've done the calculation. The calculation is quite simple in Excel. We take an empty cell, could be any cell here, we click in it, and we tell Excel that we're going to be using one of the functions by typing in an equal sign. We then type in norm, and you can see here that there are quite a number of normal distribution functions that we can choose from. We're going to select the one that says norm.dist, and we double click on this in order to select it. And what we're going to see here is that underneath this function, which is now opened up, we can bring our cursor down and actually see what this function is going to do for us. If I bring my cursor down here, I can click on norm.dist, and I can get to the Excel help that's going to tell me a little bit about what this function is going to do for us. In this case, we see that the norm.dist function is going to return the normal distribution for the specified mean and standard deviation. This function has a wide variety of applications. There is an explanation that follows on the syntax for this particular function. And we see here we've got the norm.dist function, and the first thing we're going to be putting into Excel is the X, or the score. We're going to put a comma, we're going to put in the mean, we're going to put in a comma, we're going to put in the standard deviation, we're going to put in a comma, and then we're going to indicate in this last portion of the syntax whether this is a cumulative function or not. These various aspects of the function are defined for us under this help function. So we need a score, which is our X value, for which we want the percentile rank. We need the mean, we need the standard deviation, and you can see for the last part of this we are going to type in the words true, which indicates that this is a cumulative function. We're going to always put in the word true here. It indicates that we're interested in the cumulative number of scores. Essentially, we want to get what's at or below that particular X score. Coming back to our sample problem, I come over here. Remember that the first thing that it's going to be asking for is what is the X? In this case, we're being asked to determine the percentile rank of a partial score up of 11. So I'm going to type in 11. I'm going to put a comma. The next thing that's being asked for is the mean. In this case, I can see that the mean number of partial curl-ups for women of this age group was 16. I'm going to put a comma. And the next thing that's being asked for is the standard deviation. I'm going to put in 2.5. I'm going to put a comma, and I'm going to type out true, and I'm going to close the parentheses. I can then hit enter, and I can see that the percent is displayed. This is the percentile rank of a partial curl-up score of 11 using Excel. Okay, so we now see that we have, once again, the answer to our question. This is the percentile rank of a partial curl-up score of 11. And we can display this percentile rank in a couple of different ways. We can use the percentage, which happened to pop up in this particular scenario, or we can come up here and here we can indicate the way that we would like our numbers displayed. You see right now that you have the option of percentage. You can just change that by pulling the pull-down menu, hitting on a number, and we've now put it as a decimal. We can go back to percentile or percentage by clicking on percentage down here. Or alternately, what we can do is we can come up here in the screen and simply click on the percent, and we see that it is displayed in this way. If you would like to express your answer out to more decimal places, you can come up to this portion of Excel, and you can see that you can show more decimal places by clicking here, and now we're back to an answer that we feel very comfortable with. Let's go ahead and solve this next problem. You see in this next problem that once again we're assuming a normal distribution of scores. Very important. You can't use any of these norm functions in Excel unless you are assured that you have a normal distribution. But in this case we have a normal distribution of what are called hexagon scores. The hexagon test is an agility test, and we can see here that the agility test is such that lower scores are going to be better because we're timing the number of seconds for you to complete a certain agility test. We're being asked in this question to determine the percentile rank of a hexagon score of 11 seconds. And so let's go ahead and solve the problem. We find an empty cell. We type equals. Remember, we are always figuring out what is the percentage of scores that are at or below a given score by using the norm.dist function. I double click on it. I add into there the X, or the score of interest, in this case 11 seconds. I'm going to type a comma. It's asking for the mean next, that's 12.87. I'm going to type a comma. It's asking for the standard deviation next, so I type in 1.48. I'm going to put a comma. Once again, I'm going to write out true. I'm going to close my parentheses, and then I hit enter on my keyboard in order to display the percent. Now, beware, this is not the final answer. Remember in this case that lower scores are better. That is, if you can complete the hexagon in fewer seconds, you theoretically should have a higher percentile rank. And we see that this score of 11 seconds is much better than the mean of 12.87. So I'm hoping that the percentile rank that I come up with is above 50%. So what do I do in order to get the percentile rank that corresponds to the score of 11? You see up here that if lower scores are better scores, we're going to take the answer that we get using this norm.dist function, and we're going to subtract that from 100%. So I'm going to come over here to an adjacent cell. I'm going to type equals, and I'm going to write 1, which is the same thing as 100%. I'm going to subtract from it the value that is in this cell by clicking on that cell, and I'm going to hit enter, and I come up with my final answer. So again, we can see that the final answer in the first scenario is shown as the percentile rank is 2.275%. 2.275% of the scores are at or below a partial score, curl-up score of 11. In the case of a hexagon score, we can see that 89.68% of the scores are at or below 11 seconds in this particular test where the mean and the standard deviation are given. The final thing we need to do is to kind of solve these problems backwards so it makes sense. We're going to use a function called norm.inverse. In this case, what this function is going to give us is the score x in a normal distribution that corresponds to a certain percentile rank. Okay? Once again, we're going to assume that higher scores are better scores, and if lower scores are better scores, we need to do something in advance of plugging into the function. So let's walk through a couple of examples. I'm going to come down here, and in my first example, it says, what is the score that corresponds to the 60th percentile in a normal distribution with the mean and the standard deviation that are given? So let's come down here. I'm going to type equals. Now I'm trying to figure out what's the x that actually corresponds, in this case, to the 60th percentile. So you're going to see here, I'm going to type in norm, and I'm going to choose norm.inverse by double-clicking on it. The first thing I'm being asked is the probability, and that would be given in a decimal form. So the 60th percentile would correspond to 0.60. Next, you see in this syntax, I'm being asked to put a comma. I then put the mean, which is 16. I put a comma, and then I'm going to follow that with the standard deviation, which in this problem is 2.5. I close in my parentheses, I hit enter, and now I have an answer. And that is a score of 16.63 for partial curl-ups in these women is going to correspond to the 60th percentile. Is going to correspond to the 60th percentile. The very last problem is kind of different. Here, again, we're being asked to figure out the x, or the score that corresponds to the 60th percentile. Only here we're talking about hexagon scores, and you'll recall with hexagon scores that lower scores are better scores. So if lower scores are better scores, you need to start by taking the desired percentile, subtracting it from 100% before performing the Excel function. So in this case, I'm trying to figure out what is the 60th percentile, but things are kind of backwards. So I'm going to take 100%, I'm going to subtract 60, and when I'm asked to plug into my function, I'm actually going to plug in the 40th percentile. Down here, I choose a cell, I write equals, I type in norm.dist. I'm going to double click on that function. The first thing I need to put in is my x, and in this case, oops, I used the wrong function. Let me go back. I'm going to type in the norm.inverse function, and you see here the first thing that I'm being asked is the probability. We said that we wanted to find out what corresponds to the 60th percentile, but because lower scores are better, I'm going to plug in this probability, and I'm going to make it 40% or 0.40. I put a comma, I plug in the mean, 12.87 seconds. I put in a comma, I put in the standard deviation, 1.48 seconds. I close my percent so that my syntax function is complete. I hit enter, and now I have a final answer. We now know that the score that corresponds to the 60th percentile in a normal distribution for hexagon scores will actually be 12.49. This score is faster than the mean, so it makes sense. It certainly would be above the 50th percentile, so all looks good. Thank you.